Good morning, everyone, and welcome. I'm glad to see you all. So, how did you like your 2-week warm-up act? I guess it was more than that. You got excellent teaching and practice on the computer, and we're going to try to build on that. I think you're very smart to either come for these 2.5 days or stay on for this 3rd week, because you will be the first kid on the block who know about Mplus version 7. And I think it will provide you with a lot of interesting new research activities, be it for methodological purposes or for substantive purposes. There are lots of work that can be done here for the first time, new kinds of substantive analyses, and certainly there's a lot of need for methodological investigations, because Tihomir and I have had relatively little time to play around with a computer program ourselves in the extensive fashion that's required to write papers. So we invite you all to help us investigate these new methodologies. There are lots of careers, if you're a professor or researcher, careers can be formed based on version 7, I predict. But without further ado, I would like to introduce you to a person whose name you've seen on very many papers, and now, perhaps for the first time for some of you, you will see him in person. Ladies and gentlemen, Tihomir Asparouhov. And Tihomir, why don't you say a few words about yourself?
Okay, how about this? One more. I have 3 kids, and one of them is at MIT doing computer science, and he helped us. He's been helping us. He's kind of started some things when he was 15, and Bengt is going to talk more about that. So.
All right. Tihomir is an interesting gentleman. We call him our local genius. This man should get a prize for all the clever algorithms he's been programming into Mplus over the years. We're very lucky to have him as part of the Mplus team. So I thought we'd just wait for the technician to come. Or we have a new technician, you Pox. I'll stand right here then. Okay. So I know this doesn't show up very big on the screen, but anyway, I thought you might enjoy just getting into the program a little bit. And this is a model that one of my former students, David Kaplan, has proposed for science achievement. We took over your job. Okay. And it doesn't matter much what the model is in detail, but it is a structural equation model in the sense that you have 2 measurement parts to the model, 2 by statements, and you have a couple of on statements here. So there are latent and observed variables involved. And we can just run it here on my slow laptop, and that worked pretty well. So we have the output here, and as usual, it's poor fit. We try to live with that disappointment and go on with life, but How about this? I guess you liked it. All right, so let's play around with it a little bit here. Let's see. This factor part did not come out in the right spot, so let's move it a little bit like that. And that looks better, right? And what about this arrow? Oh, that should maybe be like that. And how about this one, like that? Stretch this out a little bit. And you have a publication quality plot that you could export to a PDF file. And we can spend all morning looking at this here. We can show only significant paths, so that's fewer of them. And standard errors are there. We can go back and forth and get rid of them if you want to. Let's see. Let's get out of that. And let's see if we can try something different. How about if we, let's see, what about if we just, let's type something in. What should it be? And this is on my laptop that I never use, except traveling, so I will mistype. Hit the wrong button. And this is the dangers of live TV. How about and the suspense is enormous here, right? What kind of model do you want? F1 by Y1, Y3. How about F2 by Y4-Y6? And how about if we add let's make it into a mimic model, okay? So we have an X variable here. So how about F1 on X? And let's give it a label so we have something to play with. Whoa, we got into cap lock here. F2 by... It's hard to do this when you're jet lagged. Not by, it's on. B2. What else? Well, we have residual correlations, right? Y2 with Y4. And then let's save it into something. Save it as, how about Utrecht? And there, and save it. Yeah, let's replace it. Okay, so now let's just run it. Doesn't work. And we know why, right? There's no data here. I mean, how can you even believe that that could work? And how about getting a diagram without analysis and running it? There's some error here. Can somebody spot the error? Oh, models. Thank you. All right. What about now? Well, we got Tech 1 here. That's good, right? And we couldn't get much more because there is no data set to analyze. But how about this? All right. Okay, and we want to fix this up a little bit, right? And spread it out and arrange it the way you want it. And let's look here. Show parameter labels. That sounds exciting. B1 and B2, all right, there they sit, and this is something that we're working on, but let's move that B1 thing. Oh, we can move it around. Nice, okay. I'm not going to try any further because I may break it at any moment here. All right, so there, that's the second use. This is my favorite use because I don't want to have to work with freehand or other software to draw diagrams. But here you have your own drawing tool. You don't have any data, you don't have any analysis, you just draw. And this is the Mplus diagrammer included with version 7 without any problems. And it's something that's going to develop in parallel with Mplus. So it's not going to, a new version of this diagrammer can come out in between of other Mplus versions. So this is diagrammer 1.0. As you know, 1.0 things you use with care. We hope it works okay, but we're not done yet. Let's see, what else can we do, Tihomir? Well, how about this? How about Open Diagrammer? So what you have here on the left, how many variables? Let's see, 2. You draw on the left, and on the right you see the input come. All right, so there you have it. But how about this? Selecting this, and how about rotating this clockwise? Hey, that worked. Sorry, I'm not supposed to sound surprised. And I'm new at this, but let's try an arrow here. Okay, well, arrows go everywhere here after a while. But what you see is everything happens then on the right, and then you can fill in the data up here and run it. So there you have it. We're going to show you some more features as the day goes on, but I think those are the 3 essential uses. So I'll stop there, but I want to summarize it for you. And I'll do that in the following way. There you have the summary. So very often in the SEM world, we have seen the use of a diagrammer as an input. So we have so the model is specified by drawing a diagram instead of the syntax. I've always felt that was not needed for Mplus because it has a very simple language. But people have convinced me that beginners might prefer that way of doing it, so we offered it. The diagramming takes place on the left that you saw, and producing Mplus input on the right. What you saw me illustrate first was using the diagram as an output feature. You run the program as usual, and then a diagram comes up with all the results and the estimates. And you can move the estimates around on the arrows, and you can display standard errors or not, significant or not, a different kind of number of decimals, etc. And my favorite that I will use it for is as a tool for drawing, so I don't have to play around with various kinds of drawing tools. It's interesting that for years we were focusing on statistics and not on these kinds of bells and whistles, so to speak. But this gentleman over here argued for and finally convinced me that we should do this. And I think he was right. And the interesting thing, the story starts here, and that's what Tihomir alluded to. He has the son, Delian Asparouhov, who actually when he was about 15 and 16, or 16, started working on this diagrammer. So he's the instigator. He's this other genius-like person. And actually last summer, the year before he graduated from high school, he actually worked for us during the summer. And he did, for instance, the new shopping cart. He learned the PHP language. He thought he always wanted to learn that. So he did that in conjunction with writing this shopping cart that you're seeing on Mplus. But he also did the beginning of the diagrammer and made a platform for it, all kinds of generalities that we actually haven't utilized yet. And Tihomir was the father overseer of the work. And together they worked one summer. And I think that was a pretty nice collaboration. And then our interface programmer, Muthén, took over to work on the stabilization with it. And she is continuing to work on it. She's actually working on it this week to try to make it more and more stable and not break down. There are all kinds of issues when you work with drawing like this. And this is Java-based, and it's not easy to test. So we have a special tester, as you will see later on. But, of course, the next step is that's where we are going, of course, ultimately. So with that little warm-up surprise, folks, let's talk statistics. And I'm surprised that surprise was still a surprise. I thought somebody must have leaked it from the Hopkins week last week, but no. Good. So we're going to go through quite a lot, as you see here, from the table of contents, and you have the handout for the 3 parts. And the 3 parts correspond to the pretty much 2.5 days that we have together. And we got this extra screen because we like to show you things in parallel. Formulas on one page, model diagrams on the other, or input on one screen rather, and the model on the other. So here is what Mplus looks like. If you wondered, we have a map here, and the states are not only red and blue for Mplus. Red and blue states meaning conservative and Democrat, and I can never remember which. I think the Democrats are the blue states, which always was against my feeling. I thought Democrats were red and conservatives were blue. So we have yellow and green states here. I don't quite know what that means, but it's an interesting idea. So the program team was always West Coast oriented. We have Linda and I here in LA, and Michelle Kahn is also in LA. She is the office manager of Mplus, and she also happens to be our daughter. So treat her well. Up here in Salt Lake City, climbing the cliffs and digging into the grottos of Salt Lake City's area of fine national parks is Tihomir. Down here in Costa Mesa, about an hour's drive south from us, is Muthén. And we wanted to be bi-coastal, so we also have a new member, Sarah Hastings in Massachusetts, who is a tester for us and also works with me on various matters. Now, somebody may look at this map and think that we have these corporate headquarters all over the country. No, this is people working in their bedrooms or garages. So everybody's working from home, and we're telecommuting. The first 5 years or so, we actually had offices on the west side of LA, where it's all started through a small business innovation research contract, which supported several people as a startup, opening those offices. And we worked together, all of us, but then we realized we didn't need to be together. We knew each other, so we could work from home more conveniently. So that's what we're doing right now, and it works quite well. Tihomir and I talk on the phone quite often, and email even more often, and emailing is the main communication for us. Why did we go into this? Well, it was surprising because after I made my first program, ListComp, which was distributed by Scientific Software, I promised that I would never deal with software anymore because it eats up too much time. But then the National Institute of Health said that we have money to support development where you can actually have a large team that help out with everything. And we went for it. Linda and I applied for this grant and got it going. And the idea, the background, the rationale for starting it was the following, that, and you can look at any screen. We felt there were so many great ideas that came from biostat and psychometrics in particular, but from other fields as well, that were underutilized in practice, perhaps especially in the social and behavioral science applications. And we wanted to put them out into the hands of people who do analysis. And it's hard to catch all these new methods because they are technically described in many different journals, like Journal of the American Statistical Association or Biometrics or Psychometrica, and they can be hard to read. And people do make software, but they're often very limited, that just work for their kind of application. It's not for general consumption. What we wanted was an integrated framework, which was easy to use and at the same time very powerful. So very general modeling capabilities while having a very simple language. And I think we have achieved that. I want to emphasize one thing. I do not view Mplus as an SEM program. To me, Mplus is not an SEM program. You may be surprised to hear that. But I think a much more general conception is to look at Mplus as a general modeling program, and particularly latent variable modeling. So the general theme that makes it hang together is latent variable modeling. And that covers much more than SEM. I also don't like to use the term SEM because it's not a term that's looked favorably upon by mainstream statisticians. There have been too many strong causal claims in the SEM literature, and there's actually been a trend against SEM. So, but if you talk about latent variable modeling, well, that's something even biostatisticians are very excited about. So you reach more people if you use the term latent variable modeling, and that's what I use. But there's several programs in one. It's a very good path analysis program. It's now an extremely good exploratory factor analysis program. I would even argue that there is not a better exploratory factor analysis program. I think it is the best. I'll throw modesty rather aside totally here. It is the best SEM program. It is also a very advanced IRT program, which not everybody knows, particularly now with the new features it is. It does growth modeling in an excellent and general fashion, and then mixture modeling or latent class analysis in quite a general fashion, which is interesting in a longitudinal setting where you have so-called hidden Markov modeling or latent transition analysis or latent class growth analysis or growth mixture modeling, which has become very, very popular. But it also covers survival analysis, both continuous time, Cox regression, and discrete time, multi-level analysis, and now even more general with version 7, and the complex survey data analysis features, where particularly Tihomir has written a lot, and with the version 6 edition of Bayesian analysis, it's become quite a complete program, including Monte Carlo simulations that where you can check your results. And it's not these separate pieces going down different tracks. What's special about and unique about Mplus is these techniques are fully integrated. They can be done together in a general latent variable modeling framework. So for instance, you can do EFA together with SEM. You can have an EFA measurement model in an SEM general framework. That's what we call ESEM. So you'll hear about ESEM here now, where Tihomir took the lead and wrote an article in SEM, or SEM journal. But you will also hear about BSEM, where we combine Bayesian analysis with structural equation modeling. But all of this is concerned with latent variables. You have the classic factors in EFA and SEM and IRT, but you also have random effects, the growth factors in growth modeling, and categorical latent variables here. And in survival analysis, you talk about frailties, unobserved variables that contribute to your problems, your disease. And in multi-level analysis, you have latent variables of components on different levels of variation. And in Bayesian analysis, you have the priors. Priors are latent variables. And actually, here's an interesting idea for statisticians. How about having a prior, Tihomir? He's drinking his 8th cup of coffee here of the day. He usually goes to 10. If he goes over 10, we have to stop him. So how about this, Tihomir, having a prior as a dependent variable in the longitudinal model, which gets updated by earlier experiences. So why not put all of those variables together? So you can do here all kinds of combinations like, let's see, mixture and growth modeling together can create very interesting missing data modeling. Not the usual MAR, but you can have non-ignorable missing data modeling, as we have papers on. And survival analysis can be combined with mixture modeling, where you have different classes of long-term survivors, for instance. So how many of you are actually here today who have been here for the previous 2 weeks? Okay, that's quite a few of you. So you're a latent class of long-term survivors. How many of you are here for the first day? Wow, that's about half of you. And how many of you don't like to raise your hands? That's standard. Steve Martin gets the credit for that. Okay, so let's talk about some news then. What's new in version 7? And we don't quite know from day to day. Actually, when we get back, we have 1 more week to play and maybe add something new. I mean, it drives the other team members crazy when Tihomir and I, we're like addicts. We enable each other to go that little extra step. And then the rest of the team has to sort of clean up our mess. So 5 big new features. We have the surprise, and I think it was a surprise, right? Yeah. Did you expect this? No, never in a million years, right? Christopher Bratt expected it. Why?
I was sitting yesterday at the terminal, okay, what are they going to give us? I saw the playlist, you might remember that. Okay, and this one has sort of, he's going to give in.
Well, I was always for a diagram as an output thing. I just didn't want to spend time on it. Yeah, all right, okay. Anybody else thought about it? No? Okay. We don't know if we can surprise you this much with in version 8, but we'll try. So there are lots of new features. New features in factor analysis. We're going to talk a lot about bifactor analysis and Bayesian factor analysis. We're going to talk a lot about analysis of several groups and introduce a concept of approximate measurement invariance, which for the first time in your life actually will mean that you have a well-fitting multiple group model. And we're going to talk about 2 new approaches. One Bayes approach and one 2-level approach that is not necessarily Bayes, but it is going to be Bayes here. So it's going to be a lot of Bayes. And I hope Renz has prepared you well for Bayes. I think he has. Okay. And then we're going to talk about analysis of individual differences, which is a popular topic in psychology. There's a whole category of psychology, right? Individual differences psychology. And we're going to talk about mixture analysis, of course, the hallmark of Mplus. And we're going to introduce an interesting feature. It's a new feature. That is, the feature did not exist July 15, but in the last month or so, we thought we should throw that in. 3-step approach. We have some novelties for latent transition analysis to make that easier to do because it can be hard at times. And we're going to tell you about exploratory latent class analysis, exploratory with the help of Bayesian analysis. We have 5 more big features on the right. This is where it started. In conjunction with one of those contracts with the National Institute of Health, we did 3-level modeling, and that was done, says Tihomir, about 3 years ago. But we wanted to hold on to that and have a fuller package. So we added cross-classified SEM. And at first, I didn't think that. I thought we should do it to be more complete. You know, if you read multi-level books, it's 3-level modeling and then random effects, or cross-classified SEMs, or cross-classified analysis rather. I wasn't too excited about it, but boy, was I wrong, because there's so many new wrinkles to that, so many new things that you can do once you open up that possibility, and you'll see that. We're going to talk about modeling where not only the individuals are randomly sampled, but also where contexts or situations are randomly sampled. So we're going to talk about more than one random mode, which you see in modern psychometrics. And it relates to IRT analysis with random items, when you sample from an item bank. We're also going to talk about longitudinal analysis quite a lot and come back to the concept of approximate measurement invariance. And once again, we're going to offer 2 solutions, a Bayes approach with multiple time points, and we're going to call that a Bayesian approach, and a cross-classified analysis. And we're going to talk finally on Wednesday morning, analysis of changing membership across time. 5 other new features, more details added. We have something called parallel analysis, which I'm not going to have time to talk about much, but it's a way to use in EFA to decide on the number of factors by looking at the eigenvalues. You know, they're supposed to drop sharply, and you're going to find that elbow. Well, I guess that's hard to illustrate. But you never know exactly. It's not really statistical judgment so much as descriptive. But we're going to do it by sampling, by drawing random data and see what the eigenvalues look for random data of that sample size, and then see which eigenvalues lie above the randomly obtained data's eigenvalue plot. You can read about that. We have it in the user's guide with references. We're going to introduce loop plots. So we're actually going to do some plotting over a loop of values, which can be used to plot moderated mediation, cross-level interactions, and so-called sensitivity analysis and causal effects modeling. By the way, causal effects mediation modeling was mentioned on the schedule here. We won't have time to talk about it, but on Thursday in the Mplus users group meeting, I will devote half of my time to talk about this paper I wrote on the topic of causal effects. And it includes sensitivity modeling. That's the etc. up here for the loop plot. Tihomir is going to tell you about base plausible values, which is the base version of factor scores, where for each individual you don't only get one factor score, and not only one factor score and the standard error for it, but you get a whole distribution of plausible values for that one individual, for that one factor. And that's what's used in more serious work when it comes to latent variable score estimation. Tihomir is going to talk about a 2-tier algorithm, which has become popular in psychometrics. And we have a whole bunch of new convenience features. You're going to start to love not only loop, but you find do be very convenient. Cuv and diff and do diff, and model all free. And you're going to enjoy auto-labeling maybe already this afternoon in the computer session. And by statements where the factor loadings are actually random, not fixed quantities, and all of these new techs. So we're going up to tech 16 now. So it's a lot of new stuff, but nevertheless, you probably aren't satisfied. So everybody has their own favorite thing, and we know people send their wishes. We have a long wish list from you. And we have our own list, which is accumulated to about 50 items. And every week, Tihomir and I say, we should start working on those 50 items. But we get excited about something else newer. And now we're forcing ourselves, Tihomir, for 7.1, and they usually happen about 6 months after the 0.0 version. 2/3 of our work, Tihomir, should be on the bread and butter wish list. And only 1/3 can be on the modern new developments. Is it okay? Sure. And you heard it here. But we do enable each other to go off on tangents. So it'll be version 7.1, 7.2, and typically on average 2 years after, if everything goes well, we'll have version 8. So it's not a static product. It's something that goes forward and goes forward quite dizzyingly fast. So the schedule is the 3 parts. And we adjust the time on the fly here. We're going to try to cover the topics that we talked about, that you have in your handouts. But some topics will just be briefly mentioned, and it's for your own study. But today we're going to try to go through these topics, factor analysis and multiple group analysis. So today will be the most traditional day of the 3 parts. Part 2 starts tomorrow with more advanced topics, and Part 3 is even more advanced, which is good because we don't have any computer exercises after this, because you may have to go home and study a little bit first before you get into computers here. But today will be traditional, except for the fact that we're going to focus more on Bayesian analysis. Not a lot, but still. So let's get started. So now it starts, okay? First thing we want to say is, don't settle for using an outdated computer. You're going to waste too much time. Get yourself a good computer. Not that things are particularly slow on average, but there are some areas that take a little bit of time because you're doing something that's never been done before, really, on the PC or anywhere else. You should use a 64-bit machine instead of 32-bit. Not so much for speed advantage. I think it speeds up things on average like 10 to 20%, but the main advantage of 64 over 32-bit is that you can access more memory. And some of these heavy computations, like numerical integration with many subjects, require a lot of memory. And try to use more processors than only one or two. Use a fast CPU. So here are some PCs, rather some computers, desktops that we have in our team. Here's a PC. And it has an Intel i7 is a key thing, an i7 processor released in April. It's a fast one, which can be, well, it's 3.5 gigahertz. You should try to get over 3. It can be overclocked to 4.2. Actually, I feel a little overclocked myself here with coffee. It has 8 processors and a good deal of memory, and it is 64-bit. Macs come with powerful computation as well, 3.33 gigahertz fast CPU, 6-core, 12 processors, 2 times 6 is 12, and 64-bit. And here's my new computer. So, and I don't have any connection with Dell, but I tend to stay with Dell. And June 2012, I got tired of my old computer and went to a new one, and it's an i7. So it has 3.4 gigahertz, it's 8 processors, and moderate memory by today's standard, and it is 64-bit. And I've saved myself a lot of time in making that switch. It plays together with options that we have. We have a new processor option, which has both A and B, 2 numbers that you can give. And the first one has to do with the number of processors, and the second has to do with the number of threads. And using a number of threads may be helpful for you when you have memory-intensive computational matters. In Mplus, there is parallelized computing. So Tihomir has actually programmed some parts of the code in an effective way where you can interact with the compiler to do computations in parallel. So, for instance, with numerical integration, he can split the sample, say, in 2 parts. It does all the computations with one half of the sample, and another strand goes through the other one in parallel. And it speeds up things quite a lot. And that's for the numerical integration, which has to do with maximum likelihood estimation. It's also done for missing data patterns, but we have no benefit for it for Bayes. Multiple threads is used with start-SQL, the random starts with type-equals mixtures. And I'm not going to take time to go through the following couple of slides. In the interest of time, I'll just leave it for you to study. I'm actually going to go straight to timing here. And I want to impress on you the importance of having your fast computers. 3 computing examples. Let's focus on the third. The third is actually a growth mixture model with count outcomes. It's actually the US Philadelphia crime study. So it's a growth model with 3 dimensions of integration. It's intercept, linear slope, quadratic slope. And it's a mixture model with 3 classes. It comes from this Davidian et al. Book chapter that we wrote, Tihomir and I. And following that, we're going to look at the timing of that example on the different computers that I've had or have. So here's my oldest laptop. It's at least 5 years old. That's the one sitting over there, and I chose it only because it's light, so I can travel with it. It's not fast. It has 2 processors, 2.10 gigahertz. That's way too low to do serious computing, and it's a 32-bit. At home, I had a desktop which has 4 processors, 2 dual core is 4, and I had it for many years, and 3.0 gigahertz, 32-bit, until Tihomir said, Bengt, you should really change to a faster computer. And I got this one from in June, and 3.4 i7 64-bit. And lo and behold, here's how it goes. If I try to do example 3 on my laptop, that's computer 1, it takes 38 minutes. If I do it on my old number crunching desktop, it takes 13 minutes. Quite a drop. But switching to the new computer 3, I cut that by more than a half. And if you sit and do a lot of repeated analysis, that adds up. That's a very significant drop in time consumed. And it cost me $1,500, which I thought was worth it over the long run. So you have to stay with it and see where the fast computers are. And I don't think there's been any chip development since April. The i7 is the latest. So there you have it. So let's talk about these these different options a little bit. So we have a new loop option, and it goes like this. You have a model. Say you have a simple regression y on x, and we label that slope P1. Then in the model constraint section, the model constraint is a very useful section, or command rather. You have two new commands. You have plot. You're going to plot something called y predicted. And you do that by having a loop function here, where we're going to loop over ages 20 to 50 with steps of 1. We're going to imagine a plot where age is the x-axis, and on the y-axis we're going to have y predicted, which is the slope times age. You know, the predicted y value is the slope times the x value. So what we get here is a series of y and x values that Mplus will then compute, and you can plot it. So you get a actual plot output, a figure that you can print out. That's a very simple example. A more interesting example is to work with indirect effects in moderated mediation, for instance. You have a paper in multivariate behavior research by Chris Preacher and Rucker and Hayes. And if you look at their figure 3, you have an indirect effect as a function of a moderator. So you will end up with a plot where the moderator is on the x-axis and the indirect effect is on the y-axis. And let's take an example of that. Here is a moderately complex path model. It's actually real data from, this has to do with aggressive, disruptive behavior of children in the classroom. This is the Baltimore Public School randomized trial. We have a randomized treatment control variable here, a 0-1 dummy variable. You have a pre-test control variable, so to speak, aggression in the fall of first grade, which is the before treatment variable, a covariate to strengthen the possibility of finding significant effects. And then you have the aggressive behavior in grade 5, and the ultimate distal outcome is being removed from school, which is a euphemistic term for being kicked out of school for misbehaving much later. So you have, here you have an interaction between treatment and the aggressive behavior in the first grade, and it's typically found that initially more aggressive individuals in the classroom benefit more from the treatment. You have the equations here. You have removal, the ultimate distal, regressed on aggression at grade 5. That's the mediator, Ag5, and direct effect from the treatment, and a direct effect from the covariate, Ag1. And then you have the interaction, beta 4 times the interaction between treatment and Ag1. That interaction, we sort of have the visual depiction of that as a filled dot that connects these two variables. That means that's the interaction of the product of the two over there. And then the mediator's function of the treatment variable and the covariate and the interaction. And then we know that when you have, so you have moderated mediation, where you can express this second equation as you just algebraically rearrange the terms, and you have the gamma 1 effect times Tx and the gamma 3 times ag1 times Tx effect. So ag1 moderates the effect of Tx on ag5 and therefore indirectly on remove. So here's one way of moderated mediation can be written like this. So you see the moderation here. This term gamma 3 times ag1 moderates the gamma effect of Tx on ag5 and then indirectly on remove. Indirect effect is this. And it often comes up that one would like to see plotted what that indirect effect looks like. We get that question quite a lot, Linda and I, on Mplus discussion. And we have to say, well, just wait. So here's the input. We have the interaction variable, inter, we call that. That's this term on the left here. So we're going to go between screens quite a lot. So in equation 1, Tx times ag1, you can circle that and scribble a little bit here, saying that that's inter. We're going to use base. And here's the equations that correspond in Mplus that correspond to the equations on the left. You have remove on ag5, so we give the labels, beta 1, and the remove regression expression continues down to the semicolon down here. We have one label per line here just to keep it simple visually. And then you have the mediator on the background variables here, beta and gamma, in line with the left-hand side. And then you have in model constraint this new plot command, where we have a variable called moderate, which represents the range of the ag1 moderator. And we take that to be, ag1 is standardized, so it has mean 0 and variance 1. So we go 2 standard deviations below the mean and 2 standard deviations above. That's the range that we plotted at. And then we compute this indirect effect. And you see that this indirect effect expression is exactly the expression that we have on the left here. Right? Just going from Greek to Roman letters, and the direct effect, right? So then Mplus takes that and plots it for you, and that's what it looks like. So that can be taken straight into your paper, and you have to then understand how to reason about it. So on the x-axis is the moderation. Go from plot goes from -2 standard deviation to +2 standard deviation. Indirect effect is on the y-axis. Here is the estimate, and you see that it's on the negative end, so it means that those who are in the treatment group have fewer school removals. So that's a good effect. It's negative in value, but good in the substantive context. And you see that the more aggressive a kid is in first grade, the more the school removal tendency goes down. So it benefits those initially more aggressive. And here are confidence bands, 95% confidence bands. It's actually Bayesian credibility intervals. And you want to find then that the credibility interval at the top goes below 0 to say that it's significantly different from 0. And you see that happens around half a standard deviation above the mean of the initially aggressive. So that upper range should go down below 0 for it to be significant. And it only happens in this narrow range here, 0.25 to 0.75 standard deviation above the mean. Okay? I know I'm going fast, but this is an advanced day. Okay, the do option. And you can read about this exact plot in that Preacher, Hayes, and Rucker paper in Figure 3. Do option, it's a way to simplify our work. For instance, if you want to define differences between parameters, I think I have to stand out here to not crane my neck too much. Say that you have 2 groups and 9 factor loadings in each group. And you want to look at group differences between 2 factor loadings, between factor loadings in the 2 groups. And then this do loop is sort of a programming feature. You go from 1 to 9, replacing the number sign here. So you have diff 1, diff 2, up to diff 9, and it's lambda 1, 1, lambda 2, 1, and it's lambda 1 up to lambda 1, 9, and lambda 2, 9. The first digit here referring to group 1, group 2, and the second digit referring to the variable in question, the 9 variables giving those factor loadings. That's the same as sitting and typing out all these 9 diffs here. So it's a time-saving device. So as we go on and work, and with examples, we find that it takes too much time to type, and then we ask Twee, can you do something in parser to simplify? So this is useful in model constraints to create new parameters, and we're going to see that it's useful in this afternoon in model priors for Bayesian analysis, and it can also be used in define to just do operations on observed variables. We're going to talk about BI with random factor loadings quite a lot. It comes up in 2-level analysis where you have random effects. And in this case, you have a 2-level model, and within you specify that S1 through S10 corresponds to the 10 random factor loadings for the factor f. So on the between level, then, you can estimate the means and variances of these factor loadings. So the variances vary across the cluster units. So not all clusters have the same factor loading, but the factor loadings are variables. Variables have means and variances. Variables can be regressed on or predict other variables. So we have that bar by statement. So bar by statement, which is a lot quicker than having a series of statements like this. And I'm going to tell you about a whole lot more of convenience features, but we'll save them for this afternoon. I think we have enough to play with right now. Just a quick review here of Bayes. So take a deep breath. And how many of you are Bayesians? Okay, it's interesting. So that's about 5% here, a quick survey. So I predict that a year from now, that's going to be over 50%. Because that's how it is in the rest of statistics. Well, I would say that, here's a bold guess, mainstream statistics is 33% Bayesian, and it's growing. So actually from the beginning, Mplus was envisioned as a frequentist and a Bayesian program. When I say frequentist, you can translate that to maximum likelihood analysis or weighted least squares. And we actually had two statistical programmers, the frequentist and the Bayesian. But the Bayesian wanted to do something else and moved out of the company, and Bayes analysis was put on hold for 13 years, which actually turned out to be a very good thing because we needed to develop the maximum likelihood part very thoroughly first, because at the ground level of Bayesian analysis are the ML algorithms. So they're just used with a twist. Is that a fair comparison? Yeah, okay. Huh? Close enough, yeah. So Bayesian analysis is firmly established in mainstream statistics, so much less used outside of statistics, and particularly in the social and behavioral sciences, and I think it's a pity. And I think you will like it as you get to know it, as often happens in life. And Bayesian analysis, I think the reason that it hasn't been used much is that it has been very hard to use, software-wise. We have this excellent program, WinBugs, very general, developed in the UK with governmental support. But it is not easy to use for those who are not PhD statisticians. You have to know a lot about distributions, and furthermore, you have to know a lot about algorithms, because as it turns out, Bayes is very sensitive to how you parameterize your model. And not only in mainstream statistics, but also in the latent variable area, there are special considerations for you to get a converging Bayesian analysis. In converging, in Bayesian terms, is often called mixing. You hear Bayesian statisticians talk about this mixes poorly. That means it takes a long time or is impossible to converge for those of you who are frequentists. And actually, Tihomir has done a fantastic job of optimizing the specific algorithms for specific models that we have in the program to make them mix well or converge well. And I think, again, throwing modesty aside, I think right now Mplus is the simplest Bayesian program to use. And for us, it's been very exciting because it provides a much broader platform for new developments. Things that couldn't be done with ML can be done with Bayes. So just to convince those 95% of you who are not yet Bayesians, why do we have to learn about Bayes? I mean, we already have to learn so many new techniques. Why do you have to force us to have one more thing? We need to get back to our substantive research. Well, you can learn much more from your data. Isn't that a good reason? You learn much more about parameter estimates and model fit, and it works much better in small samples. Large sample theory, like maximum likelihood, you have asymptotic results, and asymptotics don't often kick in at reasonably sized sample sizes. But you will find, particularly in multi-level modeling, that, as Parks will talk about, that you don't need as many clusters. You know, the rule used to be 30 or 50, maybe 100 sometimes. Now you can go down to 20 and maybe even 10 clusters and do well. And priors, which is hated by some frequentists, you will learn to love them because they match much better your substantive reasoning. You have a lot of substantive theories, but you also have a lot of empirical prior results. And those prior experiences, data-driven experiences, can be built into the priors. And for those of you who are still not convinced, here's your bullet. Analysis can be made much less computationally demanding than, say, ML, maximum likelihood. Frequentists can see Bayes quite simply. When you use Bayes with non-informative priors, the priors say nothing, and that's the default in Mplus, as a computing algorithm to get answers that would be the same as ML if ML could have been done. Isn't that good enough? So see it as a computing algorithm. Tihomir and I are quasi-Bayesians only. We haven't converted totally, but we're getting there. And we're sort of thinking along these lines. But we're sort of slipping into this use of this is informative priors here. When you want to reflect your substantive hypothesis, your priors are informative. They actually carry information. But most importantly, new types of models can then be analyzed, as you will see. For instance, in cross-classified analysis that we get to, that would be largely impossible in the ML context. We have a bunch of writings on this. We try to write as much as possible on it because there's so little documentation or papers on it. Most of this is not published, but it sits on our website, posted under papers, Bayesian analysis, and one paper is on the latent class analysis category. So we have the technical implementation here, hard to read, but there you have it for those of you who are statisticians, PhD statisticians. We have our Bayesian analysis of latent variable models, all kinds of applications where we explored how Bayes works in comparison to ML. A multiple imputation technical report, plausible values technical report. I started writing an introduction. Actually, I think it's still useful to read because it goes through much more stepwise than we have time to do here. Starts with a path analysis model and goes up to factor analysis, multi-level analysis. One paper here this is the paper that we call BSEM, Bayesian SEM, and that's coming out in a few weeks in the journal Psychological Methods. How many of you actually read Psychological Methods? Does it come to most universities here in the Netherlands? Okay, that's great, because I think it's a very good journal to read about methods described in a pedagogical fashion. And that's coming out with 2 commentaries and our rejoinder. So there's a lot of meat in that paper. And that was part of the background readings that I suggested. How many of you actually read at least one of the background readings? Wow, that's looks like 35 to 40%. Good. How many of you read more than one background reading? All right, almost as many. Well, not quite. You are very well behaved, compliant. And this paper, which is unpublished, which Tihomir is going to talk about. And usually, most of the days here together, we're going to talk much more interchanging back and forth, but this start off here is mostly my part then. Tihomir is going to talk more tomorrow and the next day. He's going to talk more than I during those days. Here's an overview of Bayesian features in Mplus. We can do single-level, multi-level, and mixture models in Bayes. Categorical continuous outcomes with probit link, default non-informative priors, or user-specified informative priors and model priors. Multiple chains, we're going to explain what that is as we go on. Convergence assessment using potential scale reduction. Tihomir is going to talk about that PSR. And we're going to provide all kinds of plots. We're going to provide parameter distributions. So-called trace plots has to do with convergence. Autocorrelation and posterior predictive checking plots. Quite a lot of graphics to go with it. Multiple imputation has to do with missing data, so you don't have to do your multiple imputation in other programs if you don't want to. Mplus has a very general approach to it. It's created to create several data sets where missing values have been imputed, and those imputed data sets can be used for subsequent model estimation using other estimators, which is good with weighted least squares, which does not handle missing data well, so you can do multiple imputation as the first step. An imputation can be done by default by an unrestricted model, an H1 model as we refer to it in SEM, using several different algorithms, and including sequential regressions, which is a standard approach in the missing data literature. But importantly, imputation can also be based on a specific model, which we call an H0 model, say a factor model. And that becomes important when you, for instance, work with multi-level models, because the unrestricted H1 model is hard to estimate quite often in multi-level models, particularly on level 2. And here are advantages of data imputation, that the sets of variables used in imputation doesn't have to be the same as the analysis set. It could be a larger set. And the multiple imputation can be read in using type imputation in the data command in the second step, and summary statistics done from those different runs. Plausible values, I'm just skimming over this. It has to do with factor scores. And there's a lot of nice, we have that paper that I mentioned, and has references to background readings. It's used, for instance, in Educational Testing Service, National Assessment of Educational Progress, or the Nation's Report Card, which shows up in the US papers with some regularity. And it's interesting that their model is a huge mimic model, just a few indicators of, say, math ability, and 128, last time I was visiting ETS, 128 covariates, predicting a factor sitting in between of the two observed sets, and they estimate the plausible values for each individual and are able to create categories of proficient or basic level of math knowledge. Now, it's an ongoing project in Bayes, and don't worry, you're going to soon get your coffee break. It's an ongoing project. Features that have not yet been implemented include ESEM. So in the future, you will have not only ESEM and BSEM, but you will have BESEM. BESEM, says Tihomir, maybe. And we don't have logit link yet. We have probit. We don't have censored count and nominal variables. Don't expect that. We don't have XWidth. We don't do interactions among latent variables in the Bayes framework. Bayes is underdeveloped when it comes to weights, sampling weights. There's no good literature on sampling weights in Bayes. So you have to put the information that the sampling weights are based on as covariates. That's probably the best thing you can do. So there's a lot of literature on that. We don't have C on X yet in mixtures, although we have had an urge to include it for a long time. We can't handle more than one latent class variable. We don't do two-level mixtures, Because what happened, instead of doing that, some of which is relatively painless to do, we went in another direction. So you can see the trend here of how Tihomir and I enable each other to go off in other directions. We went into multiple group and multiple time point analysis direction. We went into two-level analysis. Random factor loadings became possible in Bayes. You can do it in AML in version 6, But you can't do very many random loadings. You know, that's the increased number of random things. Numerical integration that is necessary as an algorithm for ML becomes hopelessly heavy and impossible, but not with Bayes. There you can have many random loadings. So that becomes possible now. And we were so attracted by that that we skipped the stuff on the left for the more exciting stuff on the right. So three-level analysis with continuous outcomes, it can be done by ML and Bayes. So you should get exactly the same results as any other three-level regression program, for instance, with ML Bayes, if you use ML in the other programs and use the same convergence criteria and don't use REML instead of ML, for instance. Exactly the same results, but we also have Bayes. And with categorical outcomes, we have Bayes as well, but don't have ML. We went straight with the Bayes there. And for cross-classified analysis, Bayes only. We have Bayes EFA, factor scores, and in Bayes, Tihomir is going to quickly talk about Kolmogorov-Smirnov convergence testing. And I'm going to stop very soon here. And let's see. I think I'm going to stop right there. Now, this was an overview session. You speak.
Yeah, we switched the mic. So I'm going to talk about... okay.
Okay. Okay. Let's get me back. Am I on now? Okay. But am I on now? We usually work with two microphones, so we're a little unused to this situation, but we'll try to adapt. So we were thinking, if you have 5 minutes of questions, we'll try to answer them, and then as we go further, we start a little late, so we're a little off schedule. But when we go further, we want to have like 10 to 15 minutes question and answer sessions. So the idea is that we talk for a long while, and then without questions, except perhaps interruption like questions of clarification, and then you can scribble down the slide numbers where you have questions, and we'll have a discussion at the end of each 1.5 hours block. So how does that sound? Okay? So let's just take a couple of minutes now to see if anybody has a clarifying or any other deeper question about this introduction. Yes? Question about the new loop command, okay?
Will you be able to save the data that this sort of generates, the numbers, so you can use it?
So the question is, can you save the numbers that are being generated from Mplus? Yes. The data will be available to you, so you can plot it in any other software that you want to. That will be a file that can be read. Yes. So your favorite plot program can be used for, because the Mplus plot will be okay, but it won't have all the bells and whistles that you would find in a specialized plot program. Other questions? Yes?
Very practical question. When will version 7 be available?
When will version 7 be available? It's funny. Funny you should ask. Version 8?
Can I answer that question?
Please.
The plan was for this to be the release date, and we were supposed to have a final product. And I was supposed to go on vacation to Greece right after everyone. But I'm not going to vacation, I'm going right back home, and we're finishing it in September, I suppose. So that's the plan. So, yeah.
So what got in between was a couple of neat ideas that we really wanted to have in version 7. And we think at this point we have calmed down enough and are able to wrap it up. Actually, the program is done. As you've seen, we just want to put a little final testing polish on it. And we hope that it will be out in a few weeks. So sometime during September is what we hope for. But you never know when it comes to it's research. It's been researched the last half year in a very intensive way. And you never know how long that's going to take. But we think it's going to come out in a couple of weeks. Yeah. Any other questions? Yeah.
I just have a question about the graph design, the graphics. Can you make graphics two-level?
So I think the question is about graphics. You mean the diagrammer? Can you do two-level models? Well, our philosophy has been, we could do we have been talking about all kinds of fancy extensions, but we said to ourselves, let's be disciplined and do the simplest stuff well first, in a stable way, and then add on to it. So I think in the first version we're not going to have multi-level, although we have sort of worked on it a little bit, but we're not going to open it up to that. So that would be version 1.1 or version 2 of the diagrammer. So not yet. All right, are you ready for your first coffee break? You're dying for it, right? Okay.